So let's suppose we take the following object, a disk. Now, because the width of the disk is much smaller than the length or the height, we can make the assumption that we're dealing with a two-dimensional object like the object shown on the whiteboard. So let's suppose we take our disk and we rotate the disk in a counterclockwise in the positive direction. Now, because the disk is rotating, it is undergoing angular rotation, the object, the disk, is said to have angular velocity. Now, recall angular velocity is simply the number of radians that our object rotates per some given unit of time. So the units of angular velocity are radians per second. Now, recall that frequency is simply the number of revolutions, number of full rotations our object makes per some given unit of time. And that means the units of frequency are revolutions per second, which is known as hertz. So 1 hertz is equal to 1 revolution per second. Now, let's suppose that our circular object rotates 1 full rotation, makes 1 full revolution every single second. Now, because 1 revolution per second is equal to 2 pi radians per second, we develop the following equation. So we can represent frequency in terms of pi and our angular velocity. So it turns out that frequency is equal to our angular velocity given by our Greek symbol omega, divide that by 2 pi. So this gives us the frequency, and if we want to represent our angular velocity in terms of frequency and 2 pi, we simply take this and bring it over to the left side. And we get the following very useful equation. So this equation relates the angular velocity of the object and the frequency. So if we know the frequency, we can calculate the angular velocity, as we'll see in just a moment. Now, recall that the period of rotation of an object is simply the time required to make 1 full revolution, and it's given by a capital letter T. Now, the relationship between frequency and period is given by the following equation. The frequency is equal to 1 divided by the period. So if we want to, we can also represent our angular velocity in terms of pi and our period. So we simply replace frequency with 1 over period, and we see that angular velocity is equal to 2 pi divided by the period. So these two equations can come in very handy when we want to calculate the angular velocity knowing the frequency. So let's look at one application. Let's look at an example. An object rotates 7,500 revolutions per minute. Now, we want to calculate in part A what the angular velocity is, and in part B, we want to find the linear velocity at a point 4 centimeters from the axis of rotation from the center of our rotating object. So this is our axis of rotation. So, before we apply this formula that basically gives us a relationship between frequency and angular velocity, we have to convert our revolutions per minute to revolutions per second, because frequency has the units revolutions per second. So we have 7,500 revs per minute multiplied by 1 minute per 60 seconds. The minutes cancel and we're left with 125 revolutions per second, which is known as 125 hertz. Now, we can use this equation, simply plug in this value into the frequency multiplied by 2 pi, and we get our angular velocity of the rotating object. So 2 pi times 125 hertz, so we leave the pi as it is, and we multiply 2 times 125, we get 250 pi radians per second is the angular velocity of our rotating object. Now, in part B, we want to use another formula that relates the velocity, linear velocity, and the angular velocity. So recall that our linear velocity is equal to our angular velocity multiplied by the radius from the point to the axis of rotation. So the point to the axis of rotation is the distance, 4 centimeters. So we must convert 4 centimeters to meters. So divide this by 100 and we get 0.04 meters. So this quantity we found in part A, so 250 pi rads per second multiplied by 0.04 meters, and we get 10 pi meters per second is our linear velocity. So we can see how these two equations can come in very handy in finding the angular velocity when we know the frequency of rotation.